Hello friends, my name is Rahul. In today concept 4 we'll discuss about thermodynamic process, its path and cycle, and then subsequently discuss about steady flow. Before going to concept 4, I just want you to go through my previous 3 videos where I have discussed about concept 1, 2 and 3, and this concept will be very much utilized in to understand this concept 4. So let's discuss about the thermodynamic process. So earlier we discussed about the states, right? So in this thermodynamic state, the state is defined by the thermodynamic properties, which are the intensive or extensive in nature, like pressure, temperature, volume, entropy, energy. There are the various properties. So any thermodynamic system which is at, let's say, state 1, and its temperature is, let's say, around 250 degree. So when it is moving from 250 degree to any temperature, let's say 300 degree, so it is going from state 1 of 250 degree to state 2 of 300 degree. So the transition from state 1 to 2 is called the thermodynamic process. So it can be pressure also. If it is moving from 1 bar pressure to, let's say, 10 bar pressure or any other pressure, then this transition will be called as thermodynamic process. So whenever process occurs, it has to follow certain path. So once when it is going from 250 to 300 degree, it can go by many ways to 300 degree. Like by compressing the piston, we can increase the temperature. By giving the external heat, we can increase the temperature from 200 to 300. So there are various methods through which the process can happen, and this the method which we followed from going one state to another state is called the path. Yeah, now after path we come to the cycle. So cycle connects when there are the when thermodynamic system is coming from one state to going from one state to another state, and again if it is returning back to its original position, like suppose I went from 250 degree to 300 degree, and let's say again 300 to I went to 350 degree, and then I went to, let's say, 280 degree, and then again if I come back to 250 degree, then I completed a cycle where I came to my original or initial state. So it completes a cycle, and this cycle is completed by various paths, like going from 250 to 300 is a path, and 300 to 250, and then 250 to, let's say, 280, 350, sorry, and 282, and then 250. So the point is that the process is the transition in state, and path define how the transition is happened, and cycle define that the system has returned to its original position. Now the steady flow devices. So in case of the steady flow devices, if any property is not changing with the time within the system, then it is called a steady flow device. So that we'll discuss in detail. So let's start with the making the notes and understanding the concept in more detail. So thermodynamic process, as we discussed, any change that a system undergoes from one equilibrium state to another equilibrium state is called thermodynamic process. So this is was the initial state, and from that system has gone to the final state, and to go from these two states it has followed a path. So this is the path. So here two things are important. One is that one equilibrium state. So any state is only defined when it is in equilibrium. When it is in transient, that will not be a state, because during the transient condition we cannot measure the system properties, because they are in dynamic in nature, they are continuously changing. So in that case we need a system at equilibrium, so we can measure all the temperature, and we discussed what is the equilibrium. So to be a thermodynamic equilibrium system, it has to fulfill three conditions, right? Thermal equilibrium, mechanical equilibrium, and chemical equilibrium, that we discussed in concept 3, I guess. The main important thing that when the process is the one transition from one equilibrium state to another equilibrium state. Another important thing is that all the state is defined by the properties. So we plot the state. We always take any of two properties. Like here we are taking pressure and volume, and we are plotting the state. Here it was having certain pressure here P and volume V. Then it went to another state where pressure was P2 and volume was V2. So this can be understood by this figure also. Here this was the original state, and then piston is compressed, so its volume has decreased from V1 to V2, and because of the compression, the pressure inside this has increased from P1 to P2. So this has been shown by the on PV diagram. This is called PV diagram, pressure and volume diagram. The process diagram is plotted by employing the thermodynamic properties, and these are very useful for visualizing the properties, and some of the common properties we use to take as a coordinates are temperature, pressure, volume, and entropy also. So what are the examples? There are various processes. So here I only discussed two. Isochoric process. Isochoric means the process in which volume, this is important, volume remains constant. So it can be seen here. In this, when it is going from one state to another state, the volume is not changing, only the pressure is changing. And isobaric, in which the pressure remains constant. So this is the diagram for this. So this is going from 1 to 2, and volume is only changing, pressure is constant. Similarly, isothermal is also there, adiabatic is also there. We will discuss in subsequent. But the understanding is that what is the process and what is the path. Okay, so in next slide, yeah, path is we discuss. It is the series of state through which system passes is called the thermodynamic path or process. And next is the quasi-static or quasi-equilibrium process. So this is very important process, quasi-static or quasi-equilibrium. Kindly ignore this, what some portion is cutting. Anyhow, this is not very important. Here also this is quasi-static and quasi-equilibrium process. So what is the quasi-static process? So whenever there is a path, to understand how the system is transiting from initial state to final state, if the transition is very spontaneous, then we will not able to know what path has is followed. If it is uh, very fast, then it is difficult to track the path. So system, when it is going from initial to final, it should be very slow, so that various equilibrium states in between is measured, and then path is found out what path exactly it has followed. So we need to find out the trace or various quasi-equilibrium states. So what is quasi-equilibrium? When a process proceed in such a manner that system remain in finitesimally close to equilibrium. So it is very close to equilibrium at all the time. It is called quasi-static or quasi-equilibrium process. So in this case, the process is very slow, so that always the equilibrium is maintained. To better understand this, let's say this is a piston. In this, gas or liquid is filled, and right now the liquid pressure or gas pressure is acting on the piston, which is keeping the piston at this position. So what is the force? The piston mass and the force of all these balls is downward, and the piston pressure force is upward, and which is balanced. Now what will happen? We will just take one ball. So this is like a very small amount of mass we have moved it. So because of that movement of mass, the piston will go slightly up. Why? Because we have reduced the downwards force. So now pressure force will act on this piston, and this, since this small mass is removed, the piston will slightly move up. So this is represent a quasi-static, means we just removed one ball to allow the piston to move very slowly, so that we can trace the path of the process. Similarly, then after removing one ball, we'll remove next, and then if the way we want to occur the process, we will slowly occur the process in quasi nature. Similarly, here also these are the weights on the piston, so we'll remove one by one all the weights, and then after removing one weight, the piston will come to its new position, and this new position we can measure the temperature and pressure, or temperature and sorry, pressure and volume, and then we can find out what is the new state. Then we can remove another piston mass, and then we can find out another new equilibrium state. So slightly, so we will get as many equilibrium states as we want in between initial and final state to trace the path. But quasi-equilibrium processes are quite idealized because we have to cut this mass in infinite numbers to get the really a quasi-equilibrium process. So it's not true presentation of the actual process, but uh, we need the quasi process to understand the thermodynamic process. Non quasi-equilibrium process not able to characterize the entire system. So if the process is non-quasi in nature, then we don't know how this initial state has come to final. It may have come like this also, it may have come like this also. So we don't know how it has come. So to understand, we should know the trace through which it has gone to go for initial to final state. So in next slide, again that above part is cut, please ignore. Now what is a cycle? So as we discussed, this is the first point from where first state, then from here to here process has happened in quasi nature, and then came to 2, 2 to then went to 3, 3 to 4, and again come back. So this is completing a cycle because it is returning to its original state or its home. So in this, initial and final states are identical. Similarly, here also it has gone. This is path A and this is path B. It has drawn on temperature and entropy diagram. So this will discuss temperature, entropy, and pressure in detail in next concept. Okay, now study flow process. So study flow process means there is this implies that no change with the time. The opposite of steady is unsteady or transient. So what is no change with the time is that this is let's say it's a control volume or a system. Mass is coming in. That time the temperature is 300, 250, and this is the temperature at various pockets of the system. And let's say time, that time is 1 p.m. So at 3 p.m. that the mass is continuously coming in going out, but the temperature at the different location is not changing. Means it's steady state system. The if the property is not changing with the time, property means any property, mass, volume, energy, anything is not changing with the time, then flow is called the steady flow. And if it is not changing with the time means mass is not changing with the time inside this control volume means the mass is constant. Whatever is going in is going out. The mass conservation law is applied here. Similarly, if energy is constant, will be also constant because mass, whatever the energy it is carrying, is also living simultaneously. If the energy conservation is not there, means change in the energy of the control system is not constant, then there will be accumulation of energy which will cause rise in the temperature. So then flow will not be steady. So for a steady flow, the mass flow rate is maintained, whatever coming in is going out, and whatever the energy coming in is also going out. There is no generation of energy, there is no accumulation of the energy. Next is the uniform flow, which is not very much used in the literature, but again we have to understand what is uniform. Uniform means it implies no change with the location over a specified region. Means the if temperature is here 300 degree, it will also here 300, here also 300, 300. So there is no change in the property with the space. Whereas in steady flow, there is no change in the property with the time. Here, not with the space. Okay, now we'll solve couple of the problems. I won't solve it. I request you to solve this and then just put your answers in comment so we can discuss. In a equilibrium process, the pressure in a system, so sorry, in a quasi-equilibrium process, so what happens with the pressure? It remains constant. It varies with the temperature, is everywhere constant at instant, or increase if volume increases. Now match the list 1 to list 2 and find the correct answer. So list 1 is change of state. So where it correspond to this, then path and then process. Succession of state, one or more properties changes and change of the state for a specified path. So that's all in this lecture. You kindly solve these problems, and in the next concept we will discuss about temperature and pressure. Thank you very much.